should I handle first when I look at 1A? What should I handle first when I look at 1A? Sort of. Yeah, we're going to deal with this parentheses, but we're not doing it as a parentheses operation. What does that number on the outside mean? What does that number on the outside mean we're supposed to be doing? And please make your comments in the main chat because everybody's benefiting from each other's help. It means multiplication. And what's the fancy math word in this situation for multiplication? It starts with the letter D. What property is it? Starts with the letter D. We just talked about it quite a bit yesterday. Distributive property. Remember, we talked about that distributive property. Okay. So with distributive property, right, we have to do multiplication. Okay, we have to do multiplication, but it's a fancy multiplication. So we're going to show our rainbow. This 5 has to multiply times the n, and this 5 has to multiply times the 11. Now we are not going to be working with any of the rest. Charlie, you may have to shut down your Cami, shut down your Google Classroom, reload. I had that happen like a couple days ago. Okay, so we're not dealing with anything else. We're just showing that distribution. So all the rest of the problem we're not working with, it stays the same. So the 9n is still there. Let me do this 1 second. So we can see it better. Okay, the 9n is still there. The subtracting 4 is still there. The equal sign is still there. The 10 is still there. And it is a positive 5 that's multiplying times the n, and a positive 5 that's multiplying times the 11. Okay. So if your Cami is blank, you have to close your Cami, close the assignment in Google Classroom, reload. All right, so now we're going to go do the math for that. We're leaving everything else alone. We're doing the math for that. So the 9n is still there. The minus 4 is still there. It's going to equal, the 10 is still there. And now we have to do the math. Anytime I have a number times a letter, I just squish them together. 5n. Oops. Positive 5n. Then I have to multiply now. What is a positive 5 times a positive 11? That's what that says, right? Positive 5 times positive 11. What do we get? Positive 55. Okay, so we handle the distribution. Always step 1. If there is a parentheses, we have to handle that distribution. Okay. Now step 2, we have to handle combined like terms. I see on this right-hand side, I have 2 that are just plain old numbers. I have to combine those like terms. I have to simplify the problem before I can start doing big zeros and big ones. So I'm going to combine those like terms. I am not changing the left side, so it's still 9n minus 4. Okay, I'm not changing the left side. All I'm doing is cleaning up the right side. So how would we rewrite the right side? Cleaning it up, combining our like terms. What would be the simpler way to write it? Yeah, 65 plus 5n. 5n plus 65, same difference because it's addition. Okay, same difference because it's addition. Okay, so now we're ready for our balancing line. Now we're ready for combining and doing our big zeros and our big ones. Okay, it's not until, oops, I have the circle, but I'm going to use it anyway. It's not until we have it as simple as we can get on both sides that we would start doing our big zeros and our big ones. We always handle the big zeros first. That is handling addition and subtraction. I see addition and subtraction. So I have to handle it first by zeroing out the piece that should not be there. Which do we work with first, letters or numbers? Which do we work with first, letters or numbers? Letters. So let's go get our letters. Go grab our letters. Okay, my letters, the 9n and the positive 5n. Now, when we're working with our letters, we always move a smaller letter to a bigger letter. So what are we going to be moving? What piece is going to be moving? Which letter's smaller? Five n's are. Now we have to zero out that positive 5n. What would we have to do to zero out a positive 5n? What would turn a positive 5n into the number 0? Super close, Moses, super close. I have to, positive 5n has to zero out So what do I have to do to get rid of a positive 5n? Not just subtracting 5. That's not a 5n. 5s and 5n's are not the same thing. So if I'm going to try and get rid of a 5n, I have to get rid of a 5n by doing the same thing to both sides. So what am I going to do? Subtract 5n on both sides, correct? Okay. Okay. All right. So I'm going to subtract that 5n from both sides. When I subtract a 5n, it's from the 9n because those were the like things. Okay, those were the like things. And I have to subtract it from the 5n, which was the purpose because we wanted that to become 0. So that has to be subtracted from. Okay, so we've just gone ahead and done that. We're going to subtract 5n from both sides. When I do 5n minus 5n, that's a 0. That was the whole goal, the big 0. Okay, so what are we going to do? What's the other side going to say? Only 4n? 4n, and then what? 4n, and then what? Minus 4. And that has to equal what happened on the other side, what's left on the other side. So 65. So have we handled all the addition and subtraction? Have we handled all this? No. So we have to big zero again. So we have to big zero the numbers now. So we have to big zero our numbers. Our -4 and our 65 are needing to combine, and we move away from the letters now. It's not about big versus small. It's about move away from the letters. Okay, so what are we going to move away from the letters? What needs to move away from the letters? The -4. So how are we going to big zero the -4? What's going to big zero out our -4? Adding 4 to both sides, exactly. So add 4 to the left, add 4 to the right. Then we move our little guy so it lines up. And we put our line in. All right, that is going to make the -4 go to 0. We don't need it anymore. It's done. What is left on the left-hand side to work with then? For n. What is left on the right-hand side? What's that for n going to be equal to? What's that for n going to be equal to? 65? No, not 65. Not 65. You have to do the math. Oh, 69, because it was a 65 plus a 4. We just said that. Okay. I have run out of space. I'm going to move up here. I took it with me. All right. So are we done with all the addition and subtractions? Are we done with all the addition and subtractions? Yes, we are. So since we're done with all the addition and subtractions, we're moving on to our big one. Okay, we're moving on to our big one. Okay. We're moving on to our big one. So we need to get rid of what's with the letter. Remember, it's always about getting the letter by itself. So let's go look what's with our letter. What's with our letter? Oh, this 4 is with our letter, right? So what is the relationship of the 4 and the n? What are they doing right now? If I say 4n, what are they doing right now? They are multiplying. So we have to undo a multiply. Okay, we have to undo and multiply. Okay, how do we undo that multiplying times 4? Okay, divide 4 on both sides. Okay, divide 4 on both sides. All right, so we're going to go divide 4 on both sides. That means I have a 4n that I'm dividing by 4, and it's going to equal as 69 that I'm dividing by 4. You are not making decimals. You are not using a calculator. You do not need to. It is a waste of your time. Okay? You're leaving it as a simplified fraction. Now, can 4 simplify 69? Can 4 simplify 69? No. So this is as good as it's going to get for this problem and this problem only. But what if it was 66? Could 4 and 66 get simplified? Could 4 and 66 get simplified? Because they both divide by the same number? Yes. Could 4 and 68 get simplified? Yes. So just because we made it a fraction doesn't mean it's done. I don't want a decimal. I do want a simplified fraction. So make sure that you double check that you can't simplify the fraction more before you say you're done. Okay? You have to have a simplified fraction. Okay. Next one. All right. Do I have a distribution? In 1B? Do we have a distribution in 1B? No. Do I have more than one of the same thing on the same side? Like we had here, we had a 10 and a 55. Those were the same things. There was more than one. No. So this one's going to go straight into big 0 and big 1, except I see that we have a fraction and we have to check if we can reduce the fraction. Okay. So I see that the P is part of a fraction. No addition and subtraction, just the P. So I have to see, can I reduce that fraction? Is there a way to make the fraction more simple to work with? Okay, simpler to work with. So right now, I'm going to put it over here. It says 3/9 P. Just because they put the P on the top doesn't mean it's only there. Okay, the P should never be squished inside the fraction. So it should have been written as 3/9P. Okay, is there a way to simplify 3/9? Is there a way to make 3/9 simpler to work with? No. Is there a way to simplify? Does 3 and 9, do they both divide by the same number? Do 3 and 9 both divide by the same number? Yes. What number is that they both can divide by? I don't think 3 divides by 2. Okay, I know 3 divides by 3. Does 9 divide by 3 also? Okay, so that's what we're going to go do. We're going to reduce, we're going to simplify this fraction. Okay, we're going to simplify the fraction by dividing the top by 3 and the bottom by 3 and getting the new fraction of what? If I divide the top by 3, what number do I get? 3 divided by 3 gets me what number? 3 divided by 3 gets me a 1. Yeah. Okay. And then 9 divided by 3 gets me what? 3. So I have a 1/3 P. So I'm rewriting this fraction they gave me in the simpler form right away. Okay. We're doing that first. 1/3 1/3 arrow off P has to equal the 6 minus the 8P. Okay, has to equal the 6 minus the 8P. Okay, so we're simplifying our fraction first whenever they put our letter in a fraction, and it's only the letter, not 3P minus 2. Can't have anything else. It just has to be only the letter. Okay, so we are now ready to do our big zeros and our big ones. When we work with our big zeros, it's because we see addition and subtraction. When we work with our big ones, it's because there's multiplying and dividing. First, we handle adding and subtracting, big zero. Do we have adding and subtracting in this problem? Do I see an addition or subtraction in this problem? One-third P equals, yes, we do. We see the minus 8P. We see subtraction. Okay, so we have to do our big zero to our letters. We have a 1/3 P. We have a negative 8P. We always move the smaller valued letter over to the bigger valued letter. Who would we be moving? Who gets moved? Who is smaller in value? A 1/3 P or a negative 8P? A negative 8P. So how am I going to big zero out of there? That negative 8P. How am I going to big zero out of there? That negative 8P. Add an 8P to both sides. So we're going to add our 8P to both sides. We need our line in because we're in the balancing act now. Whatever we do to the left, we have to do to the right. Okay, so I'm going to go add my 8P to the 8P to make it a 0, right? That was the goal. The only catch is on the other side, it's a fraction. So we need to have it in common denominator or we can't do anything with it. We can't do anything with it if it's not common denominator. So I need to turn that 8P which is over 1, into something that is over 3. What would that be? What would the top become in order for the bottom to be 3? Well, what did we do to the 1 to make 3? Well, we multiplied times 3, right? So whatever we do to the bottom, we have to do the top. So we have to multiply it by 3 also. So what's our top going to become with that in mind? Now we only have to worry about this when the second side's a fraction, and it was. So what's the top going to become now? Since we multiplied top and bottom by the same number to get the common denominator of 3, what are we going to have on the top now? Not 8P. What are we going to have? Yeah, 24P. But I'm going to do the same thing I did before, which is kick the P off. Okay, we're going to kick the P off. So on the right side, we're adding an 8p because it's a whole number. On the left side, we have to add that 24 over 3p because it was a fraction. Now they mean the same thing. 24 over 3p is the same thing as 8p, but we had to do it as a fraction because the left side was a fraction. Okay? The 8p's are all gone. How many p's do I have all together now? I no longer have 1/3 p or 24 over 3p. How many p's do I have all together now? Keeping in mind, we add the tops and keep the bottom, right? That's why we did that common denominator. Yep, 25 over 3, p off the edge. Oops. That has to equal the 6. That has to equal the 6. All right. Have we handled all the addition and subtraction? Do I see any more addition and subtraction in this problem? Do I see any more addition and subtraction in the problem? Okay, so now we're going to go big ones. We got to get rid of what's with the P. We have to get rid of what's with the letter. Okay, I have to get rid of what's with the letter. What's with our letter right now? Let's go see. I have a 25 over 3p. And I need to make it go away. And right now it says multiply. Because whenever we have a number and we switch it to a letter, that means multiply. How do you undo a multiply for a fraction? How do we undo the multiply for a fraction? Think about how you undo a multiply for a fraction. When we divide by a fraction, we don't leave it the way it is. What do? We keep the first fraction. We change it to multiply, right? Keep, change, flip, right? So I have a 25 over 3. Keep, change it to multiply, change, and then I have to flip it. So what is it going to change? What's the flip going to look like? What's the flip going to look like? Yes. So we're going to be multiplying a 3 over a 25. I got to move it up a little bit. Times that 25 over 3. P stays behind. And it's going to equal a 6 over 1 times a 3 over a 25. Because whatever we do on the left side, we have to do on the right side. We have to do both sides equally. Okay. So we handled the rules to turn this into 1. Not important anymore, right? Because once it turns into 1, one-time stuff doesn't matter. All right. What's left on that side of the equal sign? What's left on that side of the equal sign? If we big 1 out, that 25 over 3, what's going to be left? What's all that's going to be left? What did I not cross out on that left-hand side? What's left? No, I crossed out the 3 over 25, canceled out the 25 over 3. Those fractions are gone. What's left? So if you want me to do it completely, I can do it this way, because the 3 cancels the 3 and the 25 cancels the 25. They're all gone. It's gone. What's left? Just the P. Yes. Okay, so we have a P and it has to equal, do the math for the right-hand side. What's going to happen? Top times top, bottom times bottom. They don't simplify. So the final answer is going to be what? Final answer is going to be what? Top times top, bottom times bottom. 6 doesn't simplify 25, so we're going to leave it. Top times top, bottom times bottom. 6 times 3 is not 150, guys. You're multiplying this side. Top times top, bottom times bottom, straight across. $18 over 25, exactly. And that's as good as it can get. And the way I know is 6 couldn't clean up 25. 1 isn't helping anything. Okay. Done. Okay. 2A. What's my first step? Yay, not a fraction. Woo! Okay, what's my first step? Gray. Look at 1A. We're going to do the same thing for 2A, right? So what am I going to do first? I see too many people missing from their cameras without their eyes showing. Please fix that. So what did we do first on number 1A? 2A is the same kind of problem. Two A is the same kind of problem. So what are we going to do first? Distributive property. Thank you. So that means this 5 has to handle the S and the 5 has to be handled with the 7. And everything else stays the same. So 5 times the S, positive 5 times 7, positive 7, right? The 5 that was already there, the equal, the 11S that was already there, the minus 12. All we did is we're showing that we're multiplying this outside number times each inside piece. We're showing our distribution. Okay, now we have to go do the math part of it. So go do our math. Do the multiplication. What would it clean up to be? Whenever we have a letter with a number, we just squish them together. So that's 5S, right? And then we have to do the 5 times the 7, which is what? Positive 35. the positive 5 that was already there, the equals 11s that was already there, the minus 12 that was already there. Okay, do we have any more distribution we have to handle? Do we have any more distribution we have to handle? No. So now we have to look for combined like terms. Does one of the sides have too many pieces? The left side does. Okay, so we have to go fix that. We have to go fix that. So we are looking at our positive 35 with our positive 5. We need to clean that up. It's messy. It's not as simple as we can get it. Okay, so we are not changing the 5s though. We're just handling combining the two things that are the same type. It could be that the two things are letters. It could be the two things are numbers. Just the point is, if I see on one side that there's more stuff than just two pieces, I have to pull stuff together. Okay. Okay. So pull those pieces together. What do we get? Pull those pieces together, positive 40, and it's going to equal the 11s minus the 12. Okay, that didn't change. We're not changing anything except the one piece at a time. One piece at a time. All right, so have I handled all distribution? Have I handled all combining like terms? If I have, and it's simplest form on each side, then that's when my balance beam comes, okay? It's the simplest it can get on both sides. There's only one of each thing on both sides. So now is when our balance beam comes. I see two pieces on the left, but they're not the same type. I see two pieces on the right, but they're not the same type. So we're as simple as we can get. So now is when our balance beam comes. And now is when we start doing our big zeros and our big ones. We always handle our big zero first, our addition and subtraction first. Okay, so when we handle our addition and subtraction first, which do we look at, letters or numbers? Which do we look at, letters or numbers? Letters. Okay, so I have a 5s on the left. I have an 11s on the right. I always move towards the bigger letter, small letter to big letter. So who are we going to be moving? The 5s. How are we going to move that 5s? What are we going to do to keep the balance? What are we going to do to keep the balance? Subtract 5s from both sides, exactly. So minus 5s from the left to create the 0. That was our goal. And then minus 5s from the right, from the 11, because it moved there. That moves it from one side to the other by doing the opposite like that. Keep not fixing that circle thing, but it's just working out okay. All right, so this is now 0. It is all gone. What is left on that left-hand side once that 5s is gone? 40. And that 40 has to equal, do the math for the right-hand side because we moved right. Six s minus 12, right? Because the minus 12 is still there. Have we handled all the addition and subtraction? No. So we have to handle another addition or subtraction. and it is the numbers. I see I have a negative 12. I see I have a positive 40. I need to move away from the letters. So which one am I going to be moving? The negative 12. How am I going to move the negative 12? How am I going to turn the negative 12 into a 0? Add 12 to both sides of the equal sign, exactly. Add 12 to the left. Add 12 to the right. Anything you do on one side, you have to do on the other. You've got to keep it in balance. Negative 12, positive 12, that is now 0. Great job. But we have to go do the math now. What is the left-hand side going to say now? 52. And it has to equal, what does the right-hand side have left to work with? 6s. And I'm going to copy this over. But when I copy it over, I'm going to flip it, okay? Because we always want the letters on the left-hand side. So 6s equals 52. Okay, letters are always left when we're done. Okay, have I handled all the addition and subtraction now? Yes, so now I'm in a big one. I need to get that number away from the letter. And that number happens to be this 6 right here. Got to get it away from the letter. It currently says multiply when it says 6x like that. So what are we going to have to do to find the final answer then? What are we going to have to do to find the final answer then? I have to undo a multiply. I'm going to have to divide both sides by 6, exactly. All right, so I have a 6s that's dividing by 6, and a 52 that's dividing by 6. Oops, I forgot to get off. You got to be real careful and get out of the fraction before you hit the equal sign. 52 divided by 6. Now, right-hand side, we have to simplify. Left-hand side, the letters by itself now, right? The 6 is now gone because 6 divided by 6 is the number 1, right? What's left on the left-hand side then? If the 6 is gone, what's still there? The s. Now we look at the fraction. Is this fraction in simplest form? Or can we make it simpler by dividing the top and the bottom by the same number? I know I can divide the top and the bottom by the same number because they're both even. So what number would I divide by at minimum? If they're both even, what number is guaranteed to divide into both of them? Every even number divides by what? 2. Okay. So at minimum, since they're both even, we could divide by 2. Okay. But we want to double check. We want it to be done right away. Can anything better? Does 6 go evenly into 52? No decimals? Okay, so then 2 is the best we can get. But if it had been like 54, or say, other numbers, so you need to be watching. You want it to be as simple as you can get it right away. If I do 52 divided by 2, what do I get? What's my new fraction going to say? 26 over what? Because we have to divide the top and the bottom by the same number. 3. And that's as good as it can get. That's as good as it can get. We don't want fraction, we don't want decimals, we don't want mixed numbers, we just want a simplified fraction. Just a simplified fraction. Okay. So now we're looking at B. Now, does this B have the same thing happening as the first B did? That the letter was by itself on a fraction? Yes, I see the second one is. However, can I simplify that fraction any? Can I make this second fraction over here on the right-hand side any simpler than it already is? Can I make that any simpler than it already is? Can I reduce it like we did up here, 3 over 9 made 1/3? No. So we have to leave it the way it is. We have to leave it the way it is. Okay. And we're going to learn a trick today. And it's going to get brought up again next week. But we're going to learn the trick today because of this problem. And it is called fraction busting. Oops, let's spell it right. Okay. With fraction busting. Didn't hear sound from somebody. Turn off your mic. With fraction busting, you are going to multiply all parts of the problem by the common denominator. Okay, you are going to multiply all parts of the problem by the common denominator. What's going to happen is all the fractions are going to disappear. It makes it really nice. That's the whole goal. So if I'm looking at, remember this 5 is over 1, right? I have a 1 on the bottom, an 8 on the bottom, and a 4 on the bottom. If I had to turn them into all the same bottom number, what bottom number would it be? What is the common denominator between 8, 1, and 4? What would the common denominator be? What's the first one that they all divide into? Not divide into them. They all divide into that number. What's the first number that all 3 of these will divide into? Not divide into them. What is the first number they all divide into? So it has to be bigger than them or equal to them. So look at the biggest number. Can the other 2 divide into it evenly? Look at the biggest number. Can the other 2 divide it? Then the biggest number is the common denominator, 8. So I'm going to take every single piece and I'm going to multiply it times 8. I'm going to take 8 over 1, because it's a fraction that I'm multiplying by, times the c plus 4 over 8. And I'm going to take And 8 times the 5. Every piece of the problem has to multiply times that 8. Now I had to do this first one as an 8 over 1 because it was multiplying times a fraction. And this one has to be an 8 over 1 because it's multiplying times a fraction. Oops, what did I do? Our goal with that is to make the fractions disappear. This is how it works. I see an 8, right? That's being divided by an 8. It's all gone. And if I divide the c plus 4 times divided by 1, that doesn't change anything. It's a c plus 4. First fraction gone. Then I have to do the 8 times the 5. What's that? What's 8 times 5? What's an 8 times 5? 40. Okay, left-hand side's cleaned up. Now we have to go look at the right-hand side. When I go looking at the right-hand side, does 8 divide evenly by 4? Does 8 divide evenly by 4? Because I'm looking diagonal. Okay, my 8 divides evenly by my 4, so my 4 would be gone, and the 8 becomes what number? If I divide 8 by 4, it becomes 2. So it's no longer an 8 times a 9c, it's a 2 times a 9c, because that 4 helped clean it up. Okay? So what is a 2 times a 9c? Because the 8 divided by the 4. So we're going to do 2 things in this step. We are going to handle this like terms. We're going to pull those together. And we're going to handle this multiply. And we're going to clean up this problem and make it as simple as we can get it. So I know I have a C, right? What is being added to the C? Combine our like terms. $44. And that's going to equal, do the math for the other side, the 2 times the 9c. What are we going to get? $18c. And that 2 times 9c came because I did this fraction buster. I multiplied every single piece by 8 to make it an equivalent equation that didn't have a fraction anymore. Okay. And the 4 on the bottom here simplified the 8 to a 2. That's why it's 2 times 9. All right. I now can do my balance B. Right. I now can do my big 0 for my letters. How are we going to big 0 out the smallest letter? What is actually in front of this C as a number that we do not see but we know is there? 1. Okay, so I need to move a 1C away, is what it's saying. I need to move that 1C away. I need to big 0 the 1C. So what am I going to do? It's a positive 1C right now, right? Subtract 1C from both sides, exactly. Minus 1C from the left. minus 1C from the right. Because whatever we do on one side, we have to do on the other. We have to keep our balance beam going. That created a 0 for that left part, but we still have the 44, right? What's the right-hand side going to say now? Do our math. 17C, because 18 minus 1 is 17, right? Okay, so do we write our letters on the left or on the right? On the left. So I'm going to change this up when I move it to give myself more space. I'm going to put it on the left like I know it should be. Okay. Okay. It's not done because I see a number with my letter. Great. It's not finished yet. Why isn't this thing done yet? I need to big one. I need to big one the number away from the letter, right? I need to big one the number away from the letter. And that is the 17C. I need to move it. I need to move that 17C. 17, not the 17C. Sorry about that. How am I going to get that 17 out of there? How am I going to undo that multiply times 17? Divide both sides by 17. So 17C divided by 17 has to equal, oops, arrow out, has to equal 44 divided by 17. Are we going to be able to simplify that, or is that as good as it's going to get? Can 17 help out the 44? No. 17 can't help out very much. 17 is kind of a mess. It's okay. Life's like that. So C is equal to 44 over 17. And there's nothing we can do about that. C is equal to 44 over 17. Okay, it's a fact. All right, now we're looking at 1A. Oh, look, yay, back to simple stuff. What do we do first? Look at 1A. Distributive property, which means we multiply that outside times each inside. Right? We multiply the outside times each inside. We don't touch anything else with the rest of the problem. We just multiply the outside times each inside. Okay. So my 9n is still there. My subtracting 7 is still there. My equal still there. The 8's still there. But it's positive 7 times n and positive 7 times the 5. Now, if it had been negative 5, you want to put negative 5 in there. If I had had a subtraction between here, I should have a negative 5 in the parentheses. But I didn't. It was positive. Okay. Go do our math. 9n minus 7 has to equal 8 plus 7n's plus what? 35. Yep. Okay, so we handled our distribution. Yay. Now we have to look. Are both sides as simple as they can get? No. Which side is not as simple as it can get? The right side. I see the right side has an 8 and a positive 35. Could my messy pieces be both letters? Yes. You're just looking that you want at minimum 2 on each side. or 2 and 1, or 1 and 2. But you don't want to have like 3 and 4 where you have a whole bunch of extra stuff. Okay, so we're combining those like terms. I still have the 9n. I still have the subtract 7. I still have the equal sign, but now I'm going to combine the like terms on the right-hand side. What is that right side going to simplify to once we pull it together? What is that right-hand side going to equal to once we pull it together? Tell me the whole thing once it's pulled together. (43 plus 7n). Oops, not b, n. Nice. Okay, so now we are ready because there's 2 on the left and 2 on the right, not a whole bunch of extra. We're ready for our balance beam line. And we're ready to start big zeroing and big oneing. Who do we do first, zeros or ones? Do we do our big 0 first, or do we do our big 1 first? Big 0, because we're handling the addition and subtraction first, always. When we do our addition and subtraction, what piece do we handle first? Letters or numbers? Letters. So I have a positive 7n, and I have a positive 9n, and I need to zero out one of them over to the other, and it's the smaller one that's moving. So who are we zeroing out? Yep, we're going to subtract 7n from both sides because 7n is smaller than 9n. And whatever we do on one side, we have to do on the other. Seven take away 7, that's all gone. Do the math. All right, that says 9n's take away 7n's. What are we going to get? That says 9n's take away 7n's. What would we get? If we have 9n's and we take 7n's away. Two n. Okay. So we have 2n minus 7 because the minus 7 didn't go anywhere, just the n's. And it's going to equal what was left on the other side. (43). Okay, are all the addition and subtractions done? Are all the addition and subtractions done? No. So we have to handle the next piece of addition and subtraction, which is our numbers, right? Our numbers. Okay, we have a -7 and we have a 43, and we need to move away from the zeros. So if we're moving away from the zeros, what would we be doing? Who would be moving if we're moving away from the zeros? Which piece has to move then? Yep, we have to add 7 to both sides. Let me shift something. If it's going to let me move that. I don't care. Add 7 to the left. Add 7 to the right. Why'd you go way over there? Sometimes. Math operation line, because we're adding and subtracting. 7 minus 7, 0. What's left on the left-hand side? What's left? 2n. And that 2n has to equal what? Do the math. 50. Okay. Yay, they gave us a problem that's going to work out to a whole number. Woo! At the very end. Okay. We're not done with our balance beam, right? Because we don't have the letter by itself yet. But we are done with our adding and subtracting. We've done with our big zeros. We're on to our big ones. Okay, I need to move the stuff away from the letters. So what am I going to be moving? I have to move stuff away from the letter. So what am I going to be moving? Yep, my 2 has to move away from my letter. Now, what am I going to do to move it away from my letter? Divide 2 on both sides, exactly. 2n divided by 2 has to equal the 50 divided by the 2. And we're excited because it's coming out to be a whole number. We know that 2 divided by 2 is the number 1, so that is gone. And what's left on the left-hand side is what? The n. And that n is going to equal, solve the math, 25. Yay, one that finally just came out simple. This is why I don't like having worksheets made by other people. They don't always pick the questions well. They just kind of generate a worksheet and yay. Okay, so now we're on our last problem. Yes, we have fractions, but it's 2 fractions all by themselves, no adding and subtracting outside the fraction. 2 fractions all by themselves equal to each other. So we get to do cross multiply, and we learned cross multiply before. So we learned cross multiply before. We're going to multiply upper left with lower right, and we're going to multiply lower left with upper right, just like we did way back. Just like we did way back. It's just a little more complicated looking now. Okay, so we're going to be multiplying the upper left with the lower right. So that is going to be a 6 times the 4 times the y plus 12. Because that's the bottom times the, right? Equaling the 5 times the 8 times the y minus 7. Okay, so we cross multiplied so that we got rid of the fraction. Because I even like math and I'm not a big fan of fraction. Don't feel bad. Okay, so we cross multiply. Okay, so first we're going to clean up the 6 times 4 and the 8 times 5 before we do our distribution. What is 6 times 4? Going to simplify to. So we are going to handle this multiplication of 6 times 4 and this multiplication of 8 times 5 first. Okay, 6 times 4 is 24. So that means the left-hand side is going to say 24, parentheses, y plus 12. We're not doing anything about the parentheses. We're just cleaning up the outsides. Okay, and the other side is going to say what? And the other side is going to say, yeah, 40 parentheses y minus 7. Okay? No. That was weird. I don't know what it did. Okay? So we did cross multiply because this is a complete fraction and this is a complete fraction. No extras that are off the fraction. So we can cross multiply. And then we cleaned up the outside. Then we cleaned up the outside. All right, so now what would we do? Looking at the problem now, what would be the next step? What would be the next step? Yeah, the distribution. We have 2 of them though. 1 on each side. 1 on each side, okay? So we're gonna go get our pencil. We need to distribute this 24 to the y and the 24 to the 12 and the 40 to the y and the 40 to the 7, okay? Distribution. Okay. All right. So go do our math. 24 times a y, still 24y. Right? 24 times positive 12. So it's a positive number. Go use the calculator. 288 equals 40 times y, so 40y, minus, because it's a negative 7, minus what? 40 times 7, 280. Cleaned up as good as we can get. We're now doing our balance beam. We're now handling the big zeros and the big ones. We're going to do our big zero first because I see addition and subtraction. 0 always comes first. Oops, I don't want that one. 1 second. Okay, addition and subtraction always gets handled first. Letters always get handled first. So we're looking at our 24y and our 40y. And who are we going to zero out and how are we going to do that? Who are we going to zero out and how are we going to do that? Who is smaller? And how are we going to move it so it becomes a 0? Exactly. We're going to subtract 24y because it's smallest from both sides, from both sets of y. It has to be subtracted from its like thing. So be careful. Do not line it up under the 280. It's not part of that 280 because it has a y attached. It has to be with the y. Okay, the 24y got zeroed out. What's left on that side of the equation? 288, yes. And that's going to have to equal, do the math for the right side. The 40 y's minus the 24 y's would make how much? 16y. And then we still have the minus 280. We haven't done anything with him. That's the next thing we have to handle. We have to big zero that 280 to the other side. The 280 has to move away from the letter by doing what? Move the 280 away from the letter by doing what? How are we getting that negative 280 out of there, guys? Adding 280 to both sides. So add 280 to the left. Whatever we do on one side, we have to do on the other. Do our math. That's 0. What's the left side going to be? 288 plus 280. What's that? You guys have calculators? What's 288 plus 280? Come on, guys. $568 has to equal the 16y, right? But we don't write it that way. So when we come up to the top, we're going to fix it. 16y equals, oops, that's supposed to be y, equals 568. Okay, we have handled all the addition and subtraction. We're now moving on to the big one. We're moving the number away from the letter. How are we going to do that? How are we going to move this 16 out of there? What are we going to do to make that 16 go away? Divide both sides by 16, exactly. Divide both sides by 16. Okay, so I'm going to get a 16y that's being divided by 16 equaling our 568 divided by 16. Now, does 16 go into 568 evenly? If it does not, we have to just reduce the fraction. If it does, good. Does 16 go evenly into 568? Use your calculator. No. So we have to simplify the fraction. What can divide into 568 and divide into 16 to make it a simpler fraction? No decimals, simpler fraction. So what numbers multiply to make 16? Does 8 go evenly into 568? Yes. Then we can divide 568 by 8 and make it simpler form. And divide 16 by 8 to make it simpler form. And what would the fraction be if we did that? What would the simpler fraction be? 71 over 2. Thank you. And that would be done. Questions about the process? I want to put a comment on this very last one, that you can cross multiply. No, not can, just cross multiply. Take out the can. Cross multiply when two fractions equal and nothing else. Okay, so this problem only had two fractions that were equal to each other. That was all the problem had, two fractions that were equal to each other. And that is why we were allowed to cross multiply. Okay. The other ones had more stuff in them than just the two fractions. That's why we had to go ahead and do the other process. All right. All right, please turn in your notes. Turn in on the worksheet. Turn in on the assignment. Turn in on the worksheet. Turn in on the assignment. If you get stuck, remember you can email me. I have to have the class here until everybody gets this turned in, please. So hit the turn in on the worksheet, hit the turn in on the assignment, please. That's why I haven't closed Zoom, because you guys aren't dismissed yet. Hit the turn in on the worksheet, hit the turn in on the assignment. Sergio, Charlie, Alec, Brianna, Gage, Kevin, Armani, Denise. Turn in on the worksheet, turn in on the assignment, turn in something so it's not a zero, please. Okay.